Let us solve a problem for half-range cosine series as well as half-range sine series. We are given the function f of x equals x defined for the range x belongs to 0, L. First, we will discuss half-range cosine series. Since we wish to have f of x having only cosine terms in the Fourier series expansion, we will define a new function capital F of x which is obtained by extending small f of x to the range minus L to 0. For this case, we will have to extend the function in the range minus L to 0 as an even function since we focus on having only cosine terms and not sine terms in the Fourier series expansion. Therefore, in the range minus L to 0, we will extend the function f of x equals x such that it satisfies the property of even function. We have capital F of x equals f of minus x in the range x belongs to minus L 0. So that we have capital F of x equals f of minus x equals minus x defined for x belongs to minus L to 0. Notice that we have this graph for capital F of x, and this graph itself ensures that the function capital F of x is even function. Since the graph is symmetric with respect to y-axis, we will have the Fourier series expansion given by capital F of x equals a naught by 2 plus summation n ranges from 1 to infinity a n cos pi n x by L into dx. For x belongs to 0, L, this capital F of x will coincide with small f of x. We will have bn equals 0 because we have extended the function as even function. We have a naught equals 1 by L integral minus L to L f of x dx. Since f of x is even function, we will have integral minus L to L f of x dx can be replaced by 2 times integral 0 to L f of x dx, where f of x equals x. Thus, we will have a naught equals 2 by L integral 0 to L x dx. By usual integration, we will have a naught equals 2 by L multiplied to x square by 2, to which we will have to give the upper and lower limits L and 0 respectively. Thus, we will get a naught equals 2 by L multiplied to L square by 2, which equals L. We have Fourier coefficient a n equals 1 by L integral minus L to L f of x cos pi n x by L into dx, where f of x is defined as even function. Even function multiplied to even function will give us even function as the product. Thus, we have minus L to L applied on even function can be replaced by 2 times integral 0 to L x cos pi n x by L into dx. Thus, we have a n equals 2 by L integral 0 to L x cos pi n x by L into dx. This can be integrated using integration by parts, and we see that this term involving sine will become 0. Here minus into minus becomes plus, and we will give upper and lower limits, after which we will get a n equals 2 by L multiplied to L square by n square pi square multiplied to cos n pi minus 1, where cos n pi equals minus 1 the whole raised to n. Thus, we will get this expression for a n after simplification. Having found a naught and a n, we have half-range cosine series for f of x equals x given by f of x equals L by 2 plus 2L by 5 square, summation n ranges from 1 to infinity, minus 1 the whole raised to n minus 1 divided by n square multiplied to cos pi n x by L, where x belongs to the range 0 to L. When you give different values for n, here inside the summation, you will get different cosine terms, and you see that this Fourier series expansion involves cosine functions only. Now let us try to expand the function in Fourier series involving only sine terms. That is, we wish to frame half-range sine series for the given function f of x equals x. For this purpose, we will have to extend the function f of x to the range minus L to 0 such that the new function defined will be odd function. That is, we will define capital F of x equals minus of f of minus x in the range minus L to 0. We have extended f of x, which is defined for 0 to L, to the range 0 to minus L such that this branch satisfies odd functions property. Since the graph of the function is symmetric with respect to origin, this also ensures that the function that has been defined is odd function. Since we have defined the function as odd, we will have Fourier coefficients a naught and a n will be 0. Thus, we will have Fourier series expansion given by f of x equals summation n ranges from 1 to infinity bn sin pi n x by L, where x belongs to the range 0 to L and capital F of x coincides with small f of x for this range. We have bn equals 1 by L integral minus L to L x sin pi n x by L into dx, where x is odd function and sin pi n x by L is also odd function. Since product of two odd functions will be even, we can replace integral minus L to L x sin pi n x by L using 2 times integral 0 to L x sin pi n x by L into dx. After that, we will make use of integration by parts and apply the upper and lower limits. We get Bn equals 2 by n pi into minus 1 into L multiplied to cos n pi, where cos n pi equals minus 1 the whole raised to n. When this minus 1 multiplied to cos n pi is considered, we will have minus 1 the whole raised to n multiplied to minus 1, which can be written as minus 1 the whole raised to n plus 1. Thus, we have obtained this expression for Bn. We have Fourier series expansion involving sine terms alone given by f of x equals 2L by pi. Summation n ranges from 1 to infinity, minus 1 the whole raised to n plus 1 divided by n sine pi n x by L. If you give different values for n here, you will get sine functions or Fourier series expansion for f of x equals x involving only sine functions.